So this is a wastewater treatment plant.
Yeah, this is a little bit different from where we were, as you can probably smell, but yes, this is a wastewater treatment plant. Right now we're standing on top of the headworks. The headwork structure is where the raw wastewater, after it goes down your drain, goes through all the underground collection system. It's pumped over here into the headworks. And right behind you there is where the wastewater is coming into the treatment plant. And this is where the treatment starts. The first part of the treatment is called screening, where we remove any solid plastic particles, paper particles, things that otherwise won't be removed, might float on the surface. We remove them here and send them directly to a dumpster that goes out to a landfill.
So this is what we flush down the drain.
Over here in these tanks? Yes and no, not really. It's not what you flush down the drain doesn't create what you're seeing in there. You see a lot of brown color in those tanks, and it's churning and aerating. And essentially what we're doing for treatment is we're using a biological process to remove dissolved organic material that's in the wastewater. Essentially we're doing the same thing that nature does, but we're concentrating it into a small area. So the wastewater is entering here at the headworks. Then it flows over to these chambers here. We mix it with bacteria. Now we grow certain kinds of bacteria that like what's in my wastewater. Well, the wastewater has the dissolved organics in it. The bacteria use those dissolved organics as an energy source. They grow more bacteria. So essentially what we got going here is a bacteria factory. We use the bacteria to remove the organics. The organics are dissolved in the water, and it's very difficult to remove from the water by the processes that are economically feasible. So we have the bacteria attack those organics in the water, use them as a food source, grow more bacteria, because the bacteria are slightly heavier than the water. So what I do is I convert all this organic material into more bacteria. Bacteria is heavier than the water, so then I take that water with the bacteria in it and put it into a tank and let it settle. And the bacteria separate from the treated water. Well, it's easy to remove the bacteria from the bottom of the tank. Then the clear water that's left behind flows on to the next process, which is disinfection. So we just take and convert all the organics to bacteria, then we remove the bacteria by gravity, leaving behind the treated water.
So where does all that bacteria actually go after you're done?
Okay, so we're growing bacteria all the time. We're probably 35,000, 40,000 pounds of bacteria every day at this plant. Well, some of it comes back into the process and does the job again. We recirculate it. But the amount that we grow every day, we try to take that out and put it into a separate process. Over here is a separate process called the digester. We put all that extra bacteria into the digester.
Why does that one look so much darker than this one?
The digesters over here are much darker. The solids that we have in there, the solids, the bacteria, the biosolids that we grow, we concentrate into that tank. Now we don't add a food source or an energy source like we do with the process up here. Here they're getting the raw organic material from the waste stream. Over there we don't give them any more food. So a lot of them die off and are converted to CO2 and water. Then the remaining part that's left over when they die off is consumed by the other bacteria as their energy source. So not only are we concentrating the bacteria, we're reducing the total amount of dissolved solids and the total amount of solids, settleable solids in the wastewater. So I may have 35 or 40,000 or 50,000 pounds of bacteria that I grow in this plant. Eventually I reduce that down to about 20 or 25,000 pounds of bacteria that eventually leaves the plant site. So the digesters help us to reduce the total amount of bacteria that we have to handle.
Where does that go?
Okay, when we're done handling it in the digesters, then it goes over to a sludge press. Over here we have a sludge press, and we'll take a look at that. That sludge press is one means of disposing of bacteria. All that does is removes the water portion from the bacteria we have in the digester, leaving behind a very highly concentrated bacteria. That highly concentrated bacteria eventually goes out to a farm, where it's incorporated with the soil and used to grow crops for feed animals.
It never really has an end to it. It just keeps going and going. And there's actually multiple benefits to this system, isn't there?
So we're treating the wastewater to remove organics, creating bacteria, using the bacteria eventually as fertilizer to grow plants. So yes, we're recycling our own waste that we treat at the wastewater treatment plant.
That sounds really simple. There has to be more to it than that.
Well, there is a lot of complex issues that we deal with, but essentially that process is it in a nutshell. Now, after we're done converting the organic material to bacteria and removing the bacteria, then there are still some other things that we have to do. And I'll take you over and take a look at that. But essentially, that is a disinfection process to make the water safe for the stream where we discharge to. Okay, this is a test the operator runs to check for the settling characteristics of bacteria. In the clarifiers that we looked at, this is exactly what's going on. The clear water is staying on the surface, the sludge or bacteria is heavier than the water, and it's settling to the bottom. And this is the process we use for clarifying the water. The organics have been converted to the bacteria settle by gravity, leaving the treated water on top.
See them right now actually floating to the bottom.
You can see some of them going to the bottom, that's right. Started up at the headworks, and we told you that the wastewater flows down into the aeration basin where we convert the organics into bacteria, and then we put the bacteria into a settling tank where gravity pulls the bacteria to the bottom and leaves the treated water on the surface. Well, this is the settling tank, or what we call a clarifier. Okay, in the clarifier we see the clean, treated water on the surface. On the bottom is a bacteria blanket, a sludge blanket that's being drawn off and being reused for the process to recycle the bacteria into the plant to do more treatment. Now the water in here is overflowing around the edges. You can see where it's coming over the trough, flows through the trough, and eventually makes its way down to the effluent basin or chlorine contact basin where we add chlorine for disinfection.
Yeah. I've been hearing a lot about stormwater pollution. How does that affect our drinking water and this wastewater treatment plant?
Well, this wastewater treatment plant eventually discharges the treated water to the same location that the stormwater goes to. It goes into the streams and the ditches and eventually goes down to the lakes. That is our drinking water source. Here though, the sanitary sewer that we discharge is treated before it's discharged. The storm sewer is not treated at all. So anything you put down into a street or out in your yard that goes down the storm sewers, it's a separate set of piping, goes directly to the streams and lakes untreated. As opposed to what you put down the drain comes here and we treat it before we discharge.
There's a lot of trash in there too.
Alright, so the dangers you hear about stormwater are things that people put out on their lawn, or grass clippings, or biocides and insecticides, herbicides they put on their yards or overuse. Those go directly to the streams and into the drinking water sources in our lakes.
What's the process going on here? What are we doing in this tank?
Well, in this tank we've added chlorine at the beginning of the tank. The chlorine sets in this tank with the water in contact for maybe an hour and a half to 2 hours. That's to kill any residual bacteria that are left over after the treatment process. So I told you that we settle the bacteria out in the clarifiers.
Yeah.
Not all of the bacteria gets settled out. A lot of it stays in the water. So we want to remove as much of that as we can. So we add chlorine, comes in contact with the bacteria. Most of the bacteria die, but not all of it, since we're just disinfecting it. Then it overflows here. Now the chlorine would go from here out into the stream, but the chlorine is bad for the aquatic life in the stream. So we have to add another chemical. In this case, we're adding sodium bisulfite. That's this liquid string that we see coming in. So the sodium bisulfite is added to the water, reacts with the chlorine, and neutralizes the chlorine. So by the time it leaves here, there's really no residual chlorine left over by the time it leaves the treatment plant.
I've heard in the future we're going to be getting most of our water from surface water from lakes like Lake Houston and other lakes around here. Is that right?
That's correct. I mean, the water we're discharging here is commingling with other waters in Cypress Creek, flowing down to Cypress Creek, and getting into Lake Houston. At Lake Houston, there's another treatment process, a treatment plant that takes the water out of the lake, puts it through the treatment process, and treats it to drinking water standards. They then pump it back into a distribution system, and we receive that water back as drinking water. Okay, so the water we're getting back from the Lake Houston, of course, we've already used that water once, it's been treated, put back into it, and we're going to use it again. So you got to think, the water's not really getting created or destroyed, so how many times has that water that we're drinking been drunk by somebody else in the past?
Or dinosaurs in the past.
That's correct.
This must be the sludge press you were telling me about.
That's right, this is the sludge press. I wanted to stop by and you could see this before we were done. This is really the final process for what we've removed from the wastewater. I told you that we put the wastewater into the treatment plant and convert it into bacteria. Take the extra bacteria we grow every day, put it in the digester. The digester, we concentrate it, reduce the total amount of bacteria in there. Eventually it makes its way over to the sludge press. The purpose of the sludge press is to remove as much water as possible. We'll probably have a total solids concentration by weight of 15 to 20% coming off the bell press. The reason for that is hauling water is expensive. So the most water that we can remove from the sludge, the less expensive it is to take that sludge out for final disposal. Now the final disposal site is going out to a farm somewhere. The sludge cake that we're putting in this dumpster here is going to be incorporated with the soil and be reused as fertilizer for crops. So essentially, the waste you put in to the water as it goes down the drain eventually gets recycled for crops on a farm somewhere.
So we really have come full circle, right?
Yes, we have.
All right, thank you, Mr. Amos. This has been interesting.
Thank you, Ryan.